Okay, so a lot of you have been really struggling with differences between approximate speed versus approximate average velocity. So I'm going to run through this scenario real quick for you. Some of you already saw it because I did it during a quizzes, but a lot of you did end up missing it. So I think it's a really good problem, actually. Okay, so right here, we see that we walk 5 meters in those first 5 seconds. So we know that's 5 meters. Pretty straightforward because we started at 0, ended at 5. For these next few meters or few seconds, we don't move at all. So our actual total displacement during that time is 0 meters because we don't change at all. It stays flat, it stays constant. And then back here from this period of time to this period of time, we move another 5 meters. We know we move another 5 meters because we started at 5, ended at 0. Because we're looking for speed, we don't need to worry about what direction we're going in. Because speed is looking for the total distance divided by the total time. We know the total time starts at 0, ends at 12.5. Time is easy. To get the total distance, all we gotta do is add up all these different distances that we traveled. So 5 plus 0 plus 5 gives us an answer of 10 meters for distance. Once we get that, all we gotta do is plug it in. So S is equal to 10 divided by 12.5 meters over seconds. Always put the units to make sure that you're consistent, and you'll get an answer of 0.8 meters per second. Okay, pretty straightforward. A little challenging just because you have to actually go through the graph and see all the different distances you travel. Now, this problem for speed, I'm going to change colors to, let's do orange. Orange is a little too similar. Let's do purple. Ooh, something fancy. All right. So average velocity this time is what this problem is looking for, but it's the same graph. Earlier, I kind of told you we don't have to worry about distance in terms of where we're going. So we didn't have to worry about whether or not they're positive or negative. But that was because we were looking for speed. Speed is scalar. Velocity is a vector. Now we need to go through and make sure we actually write in the signs. So this is a positive 5 meters because we're moving in the positive y direction. This one, we go down, back to the origin. So this is a negative 5 meters. You can even check that by doing the slope. It'll be a negative slope, meaning we did a negative direction. And velocity is not total distance, but rather it's your total displacement. So one way we can do this is do what we did earlier where we just add everything up together. This time, we just got to make sure that we note this is a negative 5. So plus a negative just means we're subtracting. 5 minus 5 means that we're equal to 0 meters for the displacement. Time is the same. Nothing changes there. We did the same total time. Or, in my opinion, the easier way to get displacement is you look at your starting position. Look at your ending position. Compare the distances. Compare the positions. So if we start at 0 and end at 0, so this will be our end minus our start, and we'll get our final answer of 0 meters for the displacement. They both are the exact same number. They're just two different ways of solving it. I personally like this method more because it's basically a guarantee of getting it. So 0 divided by 12.5, and you get your answer of 0 meters per second. Hopefully that makes more sense to you. And if you still are having problems, always reach out to me. And that's really all I have for this type of problem. We've done it a few times now, and hopefully you're getting it. But if you need more practice, you can always reach out to me, redo this quiz, go through the pair decks, etc. All right. That is it.